Hello and welcome to another video. In this video we're going to be doing the third problem from the Biweekly contest 122, which is minimize length of an array using operations. And you're given a zero indexed array nums containing positive integers. Your task is to minimize the length of nums by performing the following operations any times. Select two indices from nums such that they're both greater than 0, the values are both greater than 0. Insert the result of nums I mod nums j at the end of nums. Delete the elements at ij, and return an integer denoting the minimum length of nums after performing the operation. So let's take a look at this. So what they say is we want to pick 2 and 1, which is these numbers 4 and 3, and then we want to insert nums2 mod nums1 at the end. So basically we're doing 3 mod 4, which is 3, and we're inserting it and we're getting rid of the 4 3 in here. So we're putting in a 3, getting rid of the 4 3, we get 1 1 3. Then we want to pick 1 and 2, and we want to do nums1 mod nums2. So we'll get a 1 here, and we'll get rid of these 2. Then we have 1 1, and then when you do 1 1, we can do 1 mod 1, which will be 0, and get rid of both of those. So you get 1 here. And so yeah. So in the second example, you have this. And so the way they do it here is you take index 0 and 3. So you basically take the 5 and the 10. And then you do 5 mod 10, so you get a 5, and you get rid of a 5 and a 10. Then you have 4 5s left over, and 4 5s left over turn into 2 zeros. And in the last one, they also go through it as well. So basically, you can take 1 and 2, so you can do 3 mod 4, which will give you 3. So you have 2 3, and then you can do 2 mod 3, which will give you 2. Or you can do it any way you want. You can do either 2 mod 3 or 3 mod 2. So in this case, I did 3 mod 2, I think. Either one's fine. So pretty much for this problem, let's kind of walk through an array, I guess, and figure out what things we need to do. So let's just have some numbers. And let's just have like 1, 2, 5, 5. And we'll just have it sorted just to make it easier. So 6, 7, 8, 9, 10, 11. So first of all, for this example, notice that whenever we pick two numbers that one is smaller than the other, we can easily get rid of the bigger one, right? So the order of the numbers doesn't matter, right? We can pick whatever index for I and j. So like we can say this is I and this is j, or we could say this is j and this is I. It doesn't matter. So but whenever we pick two numbers, like let's say we pick 1 and 2, and we do this, we will get 1 here, right? So whenever we pick the numbers a and b, let's just write this down. So we pick a and b, where a is less than b, we can just get rid of b. Meaning, like I said, if you do 1 mod 2, like we would say this is I, this is j, right? We do 1 mod 2, we will get 1. And we'll get rid of both of these. So we get a 1 and we get rid of 1 and 2. So essentially we got rid of the bigger number. And you can do this as often as you like, right? So basically for this example, we can just pick the smallest number in our array and use this as our I. And then for the j, we can pick everything else and we can get rid of it, right? So we can say like, okay, let's do 1 mod 2, right? We get 1. We got rid of the 2 now and this one here. Now we could take this one and do 1 mod 5, and we'll get 1 again, right? And we get rid of this number, and we'll just get a 1. So you can basically keep doing that, keep doing that, keep doing that, and then you'll have a 1, right? So for the case where you have the smallest number and everything else is bigger, so we have a smallest number, only one of them, and everything else is bigger, our result will be 1. Okay, so that one's pretty straightforward. Now let's take a look at some more complicated examples. Like what if we don't have just a small number and only one of them? Like what if we have something weird? So let's take a look. Let's say we don't have only 1 1 now. Let's say these are all 1s, so 1 1 1. Well, what can we do here? So we can still get rid of every bigger number. And actually, let's make this a bit more complicated. So with this 1 1 1, it's not going to be super tricky, but let's say this is 3 3 3. So we can use our old strategy of just like use a 3 to get rid of everything bigger. So we can just get rid of all of these numbers, right? But just keep doing 3 mod 5, 3 mod 6, 3 mod 7, and so on. But then you have 3 3s left. So if you do have 3 3s left, what can you do from there? Well, from there, you would just take 2 3s. And if you do 3 mod 3, you get 0. So you get rid of these two. Then we have a 3 and a 0, right? So we can't do we can't pick zeros. So in this problem, we can't pick zeros. We have to pick non-zeros. So basically here, we will have 3 and 0. So we'll have two numbers. That's if we do that strategy, right? If we just take the smallest number, mod it with everything bigger, get rid of everything bigger, and then for every pair of smallest numbers, you just turn into a 0. So that would be something like you just have a count of smallest number and return the ceiling of that number over 2, right? Because for 3 numbers, you'd have 2. For 2 numbers, you'd have 1. For 4 numbers, you have 2. Essentially, every 2 numbers give you a 0. And if you just have 1 number, then you have to keep that number. But there's kind of a better strategy here. And the better strategy is basically trying to get a number less than 3. So if we can find some operation here that will give us a number less than 3, like let's say we can get a 1 or a 2, then we can use that number that we get to use our original strategy where we just mod this 1 with everything bigger, and we'll get rid of everything bigger and we'll just have this 1. So is there a way we can do that? And there is. So if we just pick, for example, so we want to get a 3 and a something smaller, right? So what we can actually do is for our first choice, instead of picking 3 and a bigger number, we can actually pick 5 and 3. So this will be I, this will be J, right? I think that's how you do it anyway. Yeah, I mod J. So if we actually do this, now we can do 5 mod 3, and we can get 2. Now we get rid of these numbers, and we have a 2. Now we can use this 2 and do 2 mod everything else to get rid of everything else, right? So basically our strategy, let's go back, is find smallest number and try to see if we can get a mod value smaller than it. If yes, return 1. If not, return this little like ceiling of the number times over 2, right? So ceiling of number over 2 of whatever the smallest number is. So if we couldn't find the 2, like for example, instead of this being 3, 3, 3, 5, and so on, what if these numbers were all multiples of 3? Then we wouldn't be able to do it, right? Like if this was like 6, 9, 12, and so on, because no matter how we would do it, we would only get 3 or more. So in that case, then it wouldn't be possible, and then our answer would just be however many 3s we can get. But that's basically the crux of this problem, is you find the smallest number, and then you go through and you try to find if you can find anything bigger. And so it turns out like if you can't find a number that's smaller than this number using this small number and one of these, you're not going to be able to find anything. Because let's say you have something like 3 is your smallest number, and then you're trying to use 2 other numbers. Like let's say we have a big number 9, so we can't use here, right? We can't do like 3 mod 9, we can't do 9 mod 3 because that'll be 0, we want something smaller. What if we have like a 4 here? Well, yeah, we can use 9 and 4, right? We can do like 9 mod 4, and that will give us something smaller than 3, we'll get 1. But notice that if that's possible, then we can also do this as well, right? Because basically, if the number is like the only way that the number and this number won't work together is if this number is a multiple of this number. And if this number is a multiple of this number, then the mod value of whatever number you're using, like let's say you're using 4 here and 9 here, it'll be the same exact thing, right? So the same thing if this was like, is that always true though? I don't think it's always true, but it will always be true that if these 2 numbers do give you a smaller mod than 3, then these 2 numbers will also give you a smaller mod than 3. Because like this can be, let's say this was 12. Actually, no, I think it would still hold up. Yeah, because this is a multiple of 4. So here it wouldn't work, but let's say we have like 16 here, or actually let's use like 15. right? So 15 mod 4 is 3. It actually wouldn't be smaller. So we would have to not use 15. We'd have to use something else. We'd have to use like 18. Yeah. So 18 mod 4 is 2, which is smaller than 3, but then also we can use this as well, right? Like if that's the case, then we can also use this. So we can try some other numbers, but basically you're going to see that like if you can take these two, you can always just take the smaller number and the one you're using. Like let's say this was 5 instead. So we can take a number like 16, right? So actually we can't take 16 because we need a multiple of 3 here. So this would have to be like, let's see, what's a multiple of 3 that 5 works with? Like 21, I guess. So 21 mod 5 would be 1, but also same kind of thing, this is 2. So we would basically need, like, in order for this not to work, this number would have to be a multiple of 3. Like this first number would have to be a multiple of 3, like 6. And then the second number would also have to be a multiple of 3, because if it was anything else, then you can use one of them, right? Like let's say this was 17 or something. Now you can just do 17 mod 3. So basically both of these numbers have to be a multiple of 3. And if both of these numbers are a multiple of 3, then it's not possible to get a mod here that is less than 3, right? It wouldn't make any sense because you'd basically get 3 or more, right? So this could be like 9 or something. Actually 9 wouldn't work. Yeah, I mean, yeah, I guess you could. 9 would work. So like you do like 9 mod 6 equals 3, but it's not. But what I'm saying is like, yeah, I think that's kind of like the proof for it is in order for these two numbers to produce something that's less than 3, they can't both be multiple of 3. But if they aren't multiple of 3, then you can just use 3. You can just take one of these numbers and mod it by 3, and you will also get something smaller than 3. That's why you can just use 3 and use it for everything. Hopefully that makes sense. And we can show this with like another number just to show. So let's say our smallest number is 5. If these two numbers that make a mod that is less than 5, so they have to both be a multiple of 5, right? Because like if they're not a multiple of 5, we can just mod it by 5 and get something smaller, right? Like if we have like 7, we can just do 7 mod 5 and get 2. And then 2 would be the smallest number in our whole array, and then we'd have one number left. So yeah, so that's what happens if they're not a multiple of 5, but if they are a multiple of 5, there's no way that like modding them by each other would give you less than 5, right? It's not possible because they are multiples of 5. So like it wouldn't be possible, right? Like there's no way. Like if you have like 20 and 25 or something, that could be like as close as you get, and this would be 5. So that's kind of like the proof behind it is in order for these numbers to give you a number that's less than 5, they both can't be multiple of 5s, but if they're not both multiple of 5s, then whichever one's not can just be modded by 5 to get a number that's less than 5. So hopefully that makes sense. But basically now our rough code is going to look like this. So let's kind of walk through this. So basically we just store the smallest number. So we'll store like 3. And then we just go through every single number and check, can that number mod 3 be less than 3? If it is, we return 1, right? Because if we ever get a min number, a new min number, and we only have one of those, like let's say we can get a 2 here, then we can just mod 2, we can just do 2 mod 3, 2 mod 3, and so on, get rid of everything else, and then there will be a 2. So if we can ever get something mod 3 that's non-zero, then we return 1. If we can't, we want to return the count of 3 divided by 2, and we want to ceiling that. So basically here we would say like, okay, we have a 5 mod 3 equals 2. We can take this operation, get this 2, now get rid of these 2 numbers, and now 2 mod everything else will just always be 2. So this should be 1. So hopefully that makes sense, and the code's going to be pretty easy. So first we want to get the minimum of this whole array. So we can just do that. We can just pre-compute that at a time. So let's just do this. So we can just say like let's just say like result equals minimum of nums. Then we want to loop through nums and just we want to have a count as well. So we'll say count to 0. So we want to say for num in nums, if num doesn't equal, actually if num mod, it doesn't matter. If it is result, it'll just be 0. So if num mod result is non-zero, that means we got a number that's smaller than result, so we want to return 1 here. And then otherwise we just keep incrementing the count. So if num equals result, count plus plus. Then finally we'll have a count of the smallest number. And like I said, whenever you have a count of the smallest number, like let's say we have like 5, 5, 5, 5. Every 2 5s will give you a 0, right? So 5 mod 5 will get rid of both of those, give you a 0. And so basically, and then whenever, if you had 1 left, like let's say we only had, let's say we had 5 5s, these 2 5s would give you a 0. These 2 5s would give you a 0, and then you would have a 5 and 2 zeros, but you can't do anything left. That's why you have to do a ceiling divide. So we would just return ceiling of result, or sorry, count mod 2. And that should do it. So yeah, so hopefully that makes sense now why you can just store the minimum number and use the mod, because there's no other way 2 numbers can give you a smaller number unless they are also going to give you a smaller number with your minimum number. Yeah, so this is basically O of n and O1 space. So hopefully that was helpful, and if you have any questions, let me know. And if you did like this video, then please like it, please subscribe to the channel. And I'll make the 4th one maybe today or tomorrow or something, and we'll start making the videos for the next one soon. So thanks for watching, and I'll see you in the next one.